The hurricane belt used to follow predictable patterns. Now it's accelerating, and this morning, a Category 5 formed 12 hours ahead of schedule. At sunrise, Category 1. 6 hours later, Category 4. A jump that should take days, not a single morning. The forecasting model didn't glitch. The physics did. The storm drew energy so fast the governing equations failed to describe it. This is the new Atlantic hurricane belt, a system that never cools, never pauses, and evolves faster than your brain is built to process. Your city gets the warning, 6 hours until landfall. Do you stay or evacuate? The danger zone isn't expanding. It's rearranging itself in secret. And if you're still using maps from 2020, you're already looking at the wrong coastline. You think you know where hurricanes come from. You think you know the shape of the Atlantic danger zone. But this year proved something unsettling. The pattern didn't widen, it broke. For 40 years, storms followed predictable patterns, forming in the deep tropics, strengthening westward, rarely overlapping in the same corridor. But this season, something shifted. 2 Category 5 hurricanes formed within days of each other in the central Atlantic, tracking paths that brought them within 465 miles, closer than any 2 major storms in the satellite era. A near Fujiwara event at full strength, a pairing that shouldn't happen where it happened, yet it did. So the question becomes, what broke? Warm water explains part of it, but heat alone doesn't rearrange storm behavior. To understand this year, you have to look at the engine beneath everything. The Gulf Stream. It's slowing down. Basic physics says a slower Gulf Stream should cool the waters north of Florida, reducing hurricane intensity in that region. And for 2 decades, it did. Which is why what happened this year makes no sense. Instead of cooling, the slowdown created something unexpected. Eddies, warm water pockets that stop moving. Heat that used to flow north now becomes trapped, lingering for weeks in the exact zone storms feed on. And warm water that doesn't move? It's far more dangerous, because a storm can sit over it for days, drawing uninterrupted fuel during rapid intensification. Sensors now reveal something stranger. A warm water lens about 200 feet down, right at the depth where major hurricanes pull their deepest energy. A hidden reservoir, suspended like glass beneath the surface. Scientists see the data shifting in real time. Your brain trusts the map you grew up with. The Atlantic doesn't. And this year, the storms follow the heat, not the historical patterns. You used to get a warning. A storm formed, models stabilized, and you had days, sometimes a week, to react. But in 2025, that buffer collapsed, because this year revealed something unnerving. Hurricanes are now accelerating faster than the forecasting systems built to track them. You saw it with Umberto. At sunrise, Category 1. 6 hours later, Category 4. A jump that usually takes days, erased in a single morning. The models didn't see it coming because they're trained on decades of ocean behavior that no longer exists. And Umberto wasn't alone. Imelda intensified 2 days later along almost the same corridor. The first back-to-back rapid intensification sequence recorded in that region. 2 storms, same zone, same trigger, trapped heat. This is the new threat. Storms that skip entire developmental stages. Not gradually, but in violent, vertical leaps. Those trapped heat pockets from Section 1 are the fuse. When a storm crosses one, it doesn't strengthen, it detonates. Rapid intensification isn't just more frequent, it's clustering. Storms feeding off the same unmoving reservoirs of heat. Each one leaving behind water still warm enough for the next to explode. And that creates a second danger, one almost nobody talks about. Psychological lag. Forecasts update faster. Warnings shrink. Landfall windows compress from days to hours. But people still react at the speed of the old Atlantic, the one where storms behaved predictably, and preparations followed a familiar rhythm. This year, hesitation became a hazard. Storms looked weak until the moment they weren't. Tracks shifted in hours. Strength doubled overnight. Which leads to the question Section 3 has to answer. If storms can jump from Category 1 to Category 5 in a single tidal cycle, what happens when they hit the coast before the models catch up? Warm, shallow water used to be our natural buffer, a slowdown zone that forced storms to lose their edge before landfall. That buffer is gone. And now 3 very specific places along the East Coast reveal what happens when a coastline was never designed for hurricanes that accelerate in hours instead of days. These are the 3 failure modes shaping America's next coastal catastrophe. The Outer Banks were never solid ground. They're migratory sandbars, meant to shift, stretch, and disappear over time. But now that storms arrive faster, the islands don't just migrate, they fracture. Recent studies show parts of the Outer Banks are losing up to 15 feet of beachfront per year, wiping out protective dunes, washing out Highway 12, and turning whole neighborhoods into breach points. This isn't a place that withstands storms. It's a place that moves when storms hit. And when hurricanes now intensify right offshore, these islands provide zero friction, accelerating the water directly into the mainland. Charleston is stunning. Cobblestones, marsh views, 300 years of architectural pride. But it was built low, on reclaimed marshland, with 18th century drainage systems designed for rainfall, not for modern storm surge volumes amplified by climate-driven sea rise. So when the new, faster storms slam into the Carolinas, Charleston becomes a bowl. Water enters easily, but drains slowly. And when sensors fail or intensification happens too fast for updated alerts, the city gets hit without the extra hours it needs to pump, divert, or prepare. Farther south, you hit a different kind of disaster. Too many people, too much infrastructure, and not enough elevation. Miami is America's most coastal dense major city. Skyscrapers, freeways, hospitals, and entire neighborhoods sitting at an average of 6 feet above sea level. Jacksonville sprawls so wide that a last-minute evacuation turns into a region-wide traffic choke. When storms now jump 2 categories offshore, these cities simply don't have the evacuation bandwidth to clear people out in time. It's not just vulnerability, it's geometry. Different cities, different weaknesses, but all part of a single, systemic coastal crisis. The geography wasn't built for modern storms, and the modern storms no longer behave geographically. And beneath every physical failure is a psychological one. It's not just stubbornness, it's the sunk cost fallacy. Behavioral studies show people consistently stay in high-risk zones because they've invested too much to walk away. Their identity is tied to the place. Leaving feels like losing everything they've built. Charleston's historic homes, Miami's condos, Outer Banks, family properties passed down for generations. When storms accelerate, these emotional anchors become deadly, because hesitation now happens on a compressed timeline. Storms sped up, but human decision-making didn't. For decades, hurricane forecasting leaned on history. Modelers took 50 years of storm data and said, this is what's likely. But the ocean underneath those statistics isn't the same ocean anymore. And in 2025, the quiet admission finally surfaced. You can't use the past to predict storms that have no historical equivalent. So modelers shifted, away from statistics and toward physics. Not what did storms do, but what can storms do in the ocean we have now? That shift revealed something unprecedented. We're entering a decade where Category 5 hurricanes become routine. 2025 already showed the opening act. 3 Category 5s in a single season, the most in 20 years. The total number of storms may not explode, but the ceiling for storm strength is rising. Modelers call it peak intensity potential. The theoretical maximum power a storm can reach given the heat, depth, and wind environment around it. And that ceiling is climbing faster than anyone expected. Warmth isn't just at the surface anymore. Deep layers are hot enough to refuel storms. Wind shear is dropping, and vast swaths of the Atlantic now hold 86 degrees Fahrenheit water or above. In simple terms, storms that once topped out at Category 3 now have the energy to push all the way to Category 5. And increasingly, they will. That's why scientists warn. The 2030s may not bring more storms, but far more storms reaching their maximum possible strength. But humans don't react to danger the way storms do. When one Cat 5 appears, people panic. When they arrive every year, people adapt downward. It's a cognitive shutdown called psychic numbing. The emotional system goes dark when threats become too constant to process. Emergency managers are already seeing the effect. Category 5 no longer shocks. Evacuate no longer triggers urgency. It's a psychological cliff, like standing on a shoreline watching waves rise inch by inch. You stop noticing the change, right up until the water reaches your chest. And that numbness may become the most dangerous force of the next decade. The forecasting failure is only the first crack. In 2025, the GFS misjudged a Category 4 intensification by nearly 6 hours. A small mistake that cascaded into missed warnings for coastal cities. This is the tangible cost of outdated systems. The deeper problem is this. Institutions update slowly. People update fast. And the gap between the two becomes a danger of its own. We're entering a decade where hurricanes change faster than the systems designed to protect us. From infrastructure, to insurance, to emergency planning. Today's entire observation network was built around storms that intensified slowly. Buoys ping every hour. Satellites update in batches. Recon planes cycle in and out. All of that made sense when a storm's biggest jump happened over days. But now the conditions that drive rapid intensification, shallow hot pools, deep warm lenses, collapsing shear, can form and vanish in minutes. Our sensors miss those pivots. Models trained on yesterday's ocean can't process today's one. Poor forecasts don't just mislead, they trigger market reactions. Insurance companies see higher uncertainty, higher perceived risk, and respond by withdrawing coverage. To keep up, we need a live ocean map, drones, underwater gliders, microsatellites, watching the heat constantly. But those systems take years to develop and deploy, requiring funding cycles and regulatory approvals. The storms don't wait. When the physical defenses crack, the financial defenses follow. Coastal cities relied on 3 layers of protection: strong buildings, good drainage, and affordable insurance. All 3 are faltering. Seawalls built for Category 3 loads are now meeting Category 5 pressure curves. Drainage grids designed for historic maximums hit that maximum every few seasons. Evacuation routes need 48 hours that the new storms no longer give. The quiet collapse comes next. Insurance withdrawal. As forecast uncertainty rises from sensor gaps, premiums spike, deductibles climb, and eventually, major insurers simply retreat. This creates economic hollow zones along the coastline, neighborhoods where the land is still there, but the financial system has already abandoned it. Once insurance collapses, infrastructure decay accelerates, and people start planning exits long before officials admit the danger. Here's the paradox. Governments plan for the future. Communities survive the present. And in high-risk coastal zones, people are already adapting faster than the official systems meant to protect them. Some neighborhoods are building microweather networks, linking cheap sensors, drones, and crowdsourced data to detect intensification hours before official forecasts update. Groups are forming mutual aid evacuation chains. Local mariners share offshore water temperature readings. Communities track their own surge thresholds. This is prosocial adaptation, the human instinct to work together when institutions move too slowly. The danger isn't that people won't adapt. It's that they'll adapt before the systems around them do. And that leads to a final shift. People start making decisions collectively to leave, not for a storm, but for good. Because once insurance collapses, utilities struggle, and neighborhoods self-organize evacuation plans. The coastline faces a final transformation. The new shoreline will be drawn by physics. But what happens when 10 million people redraw the map with their feet, rushing into inland cities that were never built for a different kind of surge? A human surge. The Atlantic is no longer predictable. Forecasting systems that once tracked storms hourly now lag. Sensors fail. Buoys go offline. The GFS missed rapid intensification events in 2025, leaving cities blind. Forecasting failure is only the first crack. When the data fails, infrastructure follows. Insurance premiums spike. Some companies retreat entirely. Coastal zones hollow out before the storms even arrive. Roads, levees, and pumping stations, built for an older ocean, cannot compensate, and humans adapt faster than institutions. Neighborhoods create micro-weather networks, crowdsourced alerts, and improvised evacuation plans. Prosocial adaptation becomes survival as formal systems lag behind. The cracks cascade. Highway routes, once lifelines, turn into bottlenecks. Cities must move in unison or risk mass entrapment. Migration becomes a force of nature itself. 10 million people, forced inland, redraw the map with every step, flooding cities unprepared for this kind of surge. Yet even in chaos, the pattern is clear. The ocean writes the rules, but humans respond. The challenge is no longer to predict or survive the storms. It's to live under their relentless acceleration. The Atlantic redraws the coastline with salt and surge. Inland, millions rewrite the map with their feet. And the true struggle of this century isn't the storms themselves, but their acceleration.